Good evening. Good evening.
Good evening, Saskar.
You feeling nice?
Yeah, I'm hearing good. How about you?
Good. Good.
Nice.
Hey. All right. How you guys doing?
Hello, hello. Good, how are
Hello.
you?
Good. Good. Give me one. Good. Good. Give me 1 second. Okay. We'll wait for a couple more minutes.
नमस्कार सरहरू सबैजनालाई
Namaste. We're gonna wait a couple more minutes for everyone to arrive.
Right, sir, no problem. Mr. Saskar.
Namaste, namaste.
Namaste.
सन्चै हुनुहुन्छ हजुरहरू?
Sunset go. हजुर.
सन्चै छ।
ठिक छ त। एकछिनमा सुरु गर्ने।
ए हस् हुन्छ हस्।
How was last class? Was it good? Learned a lot?
Yes, we were good.
Okay. Was everyone able to set up their Azure AI Foundry? Is that yes?
I think, yeah, like we got the Azure AI Foundry, but the one that we need to get for deleting,
Mm-hmm.
that is
Okay.
still like I can't access that yet.
Okay.
Yeah, I also got the Azure Foundry access. Yeah.
Okay, that's good. Okay, I think we'll start from here. So thank you everyone for joining today. I'm gonna turn my camera on here. Okay, so you can see me. So thank you for joining everyone. Today we're going to be going over some new topic. It's called fine tuning. So maybe you guys have heard of it before. I think we talked about it a couple times. So we're gonna go over model fine tuning, and we're gonna also fine tune a model in AI Foundry and talk about why um, fine tuning is useful and why it's not useful in certain scenarios, and how it can affect businesses or users, and how we can do it together. And then if we have some more time, then we'll go over how to utilize a model in code, and hopefully we can help you set up your code environment to run the code to query your own agent. Okay, so let's get started. Now, I'm going to share my screen, and I want you guys to go on Azure AI Foundry website, and then we're going to start from there, okay? So give me 1 second. Let me share my screen. This one. Okay. Before I continue, everyone has their Azure AI Foundry set up, correct? You guys are able to create agents and talk to them inside of Foundry?
Yeah, we did last week.
Okay. Okay. Just making sure no one hasn't done that yet. Okay. Ashok, I can't really hear you. If you're
Yes, sir.
Can you I don't know who's talking. There's a lot of noise in the background. Okay. I'm gonna assume that you have your Foundry set up. Okay. So please go to your resource group that you created. I created one here called Fine Tune Models Everest IT. And we're gonna fine tune a model first, and then we're gonna talk about why we fine tune. The reason that for that is because fine tuning a model on Azure AI, or in general, is a very expensive process. We're gonna learn why it is an expensive process, why it takes a lot of time to do so. So is everyone with me so far? Can you give me a thumbs up if we're all ready to do this?
I'm about to log in.
Yeah, log into your Azure AI Foundry. Okay.
For some reason, my login is not working. But I'll try. You go ahead. I'll keep trying.
Yeah. Make sure you're entering a password and stuff. Um, In that case, raise your hand if you need time to get into Foundry before we start. Okay, we need some time. Okay, then we'll wait a couple minutes in that case. In the meantime, does anyone have any questions before we start?
I'm good now. I'm in the same page as you.
Okay. Okay, so it's just Babu. Oh, that was Babu, right? Okay. Everyone good? We're all good to go? Okay. All right. So when we're in Azure AI Foundry, you might have noticed looking in the left side, there's a build and customize header, and there's we have agents, we have templates, fine tuning, and content understanding. If you go to the agents tab, you can see your agent that you created. So this is one I created today. It just has a random agent ID and an agent name, but this is agent I created. We're going to create a new agent in a second, and we're going to fine tune it off a data set. Now, this doesn't really mean much right now, but we're going to go over it once we've started the fine tuning process. Again, the fine tuning process takes some time. So hopefully when we go through what fine tuning really means, it'll be done by the time that's finished fine-tuning, okay? So let's head over to the fine-tune tab. So everyone please go to the fine-tune tab here. You're not going to see this model. This is the model I created, but we're going to create a new fine-tune model. So you can just press this blue button, the fine-tune model. And here we're going to see a couple of base models. So a base model is essentially just a model by itself. And what fine-tuning kind of means is we're going to add domain-specific knowledge and train that model on our knowledge. Okay? So we're going to choose a small model here. I'm going to choose something like GPT 4.1 Nano, or we can do Mini. I think Nano is a little smaller, so we're going to go for 4.1 Nano here. And we're going to click Next on this. We can see what 4.1 Nano does, how much context it has, all of that. If you want to look at it, you can. But we're going to click Next, selecting GPT 4.1 Nano. And here you should come to this page. So it says create a fine-tuned model. Again, fine-tuning a model essentially is just training that model on a set of data. So we're going to take a set of our own training data and then train off that data for that model. So if we click on this method tab here, there are a couple of different methods. One is supervised, the other is direct preference optimization and reinforcement. You don't need to know the differences between these three, or really that much. But what it essentially comes down to is supervised method is essentially training the model over a data set in which the model knows the answers to the training data set. Reinforcement essentially is telling the model what kind of answers to prefer from a data set. And direct preference optimization is also very similar to reinforcement. For this, we're just going to select supervised, okay? And we'll talk about maybe why later. But the difference here is essentially how the model is trained. Okay. So here's our base model. We're going to keep it on this one, GPT 4.1 Nano, 2025. I think this is April 14. And then there's a training type. There's only global here, so we're going to keep it that. And there's an option to automatically deploy when the fine-tuning is complete. We're going to set this to no because if we deploy a fine-tuned model, it can actually charge us a lot of money. So when we're done fine-tuning this model, we're going to delete it later. So let's not worry about this now. So we're going to keep it at no. Training data. So this is the most important part for fine-tuning a model. Again, we'll go over what this really means. But essentially, we're going to click on Add Training Data. And Azure AI comes with a pre-prepared sample data set for us to fine-tune off of. Later today, I'm going to have you guys generate your own data set to fine-tune a model. But for now, just for an example, we're going to select a training data set. Let's choose this one, the stock tool calling sample, in which this is the current and previous stock market queries, which covers the price retrieval using tool calls. Or actually, we could do this one as well, which is grade school math problems. What do you guys want to do? There's two options.
Stock is good.
You want to do the stock one?
Yeah, stock tool calling
Okay.
sample.
Then let's try this. Let's see. It's going to, we can click the skip preview. And basically, we're going to see what kind of data is inside of here. This is essentially a big JSON data in which we contain a lot of messages and the tools that it provides. If we do the same with the other example, you're going to see a different kind of data set here where you're given a lot of examples for how a model should respond to a specific message. Okay. So we're going to go back here to stock tool calling sample. Okay. and we're going to click apply. Okay, so now we should see stock tool calling sample here. We're also going to add some validation data. And the reason we need validation data is to validate the answers that the model produces. And this is part of the training. So the way we can add validation data is we can add existing files on this resource. And when we select data, we just have to select the stock tool calling sample right here. And if you look at the preview, it's very similar to our training data set, but this actually contains all the correct answers from the training data set. So this is, again, a validation. We'll talk more about it when we go through the explanation. But again, all of this takes a long time. So once we're fine-tuning, we're going to go into why and what fine-tuning really means. Okay. Babu, you have a question?
For the validation data, I don't know for what reason. I don't see that stock data.
The stock tool calling?
Yeah. Did I miss any steps there? I only see files from connected AI resource, upload files, non-Azure blog or others.
No, you have to select, so you have to select existing files on this resource. And then once you select existing files on the resource, then you can select stock tool calling sample in the next field.
Ah, okay, got it. It's a little bit different here. Anyways, thank you.
Okay, so once we've got the validation data set up, we're going to click apply. And here we can add a suffix, and this is just for the model's name. We can do that if we want. I'm going to call this stock agent. And the seed, we're not going to touch this. This is just a randomness variable, essentially. Now, we do have a lot of things we can change here, like the batch size, the learning rate, and number of epochs, but we're not going to touch any of this. We're just going to keep it to default settings. Next, let's just click submit. Okay, so once you've clicked submit, you should see the model has queued as a status. Give me a thumbs up if you see queued as a status for your model. You should see it like this.
I got an error. It's throwing an error saying the suffix cannot exceed 40 characters.
Okay, so you need to reduce the name of the suffix. Just make it a very short suffix.
I'm just gonna put stock. Let's see. Stock. Okay, got it. Now it worked. Thank you.
Perfect. So if you click the refresh button, this queued, essentially what this means is we submitted our agent like model to Azure, and now Azure is going to train this model. Now, training a model takes a long time. I think the one time I did this yesterday, it took me about 2 hours. I think an hour and a half or 2 hours to finish training. So this is why we went through it now. So hopefully in the future, in today's class, we will see it finished. Okay, let's go into some slides, and I want to explain to you what fine-tuning really means. Okay, so let's do that. Oh, I don't know why this is happening. Give me 1 second. I'm gonna fix this. Okay. There we go. So let me go back here. Okay. I think this is still going. Let me check on this really quick. Okay, yeah, it's still cute. So this is going to take some time. So it's going to take probably all of class to finish, but we're going to come back to it. Okay, so let's talk about fine-tuning and what fine-tuning really means. Does anyone know what fine-tuning is before I even start? Anyone have an idea of what fine-tuning really means? You can raise your hand or you can unmute. Anyone have an idea? Okay, no worries. So
Yeah,
we're gonna learn fine-tuning, and the reason why we use fine-tuning over something like RAG, and when we use RAG over fine-tuning, or maybe we use both. Okay, so let's start. So what do we know about LLMs? LLMs are AI systems, and they're AI models more specifically, and they're trained on so much text data. So if you guys don't know, the first GPT-4 that came out was trained on the entire internet. So there is a data set out there that contains all of the internet. Someone got the entire internet in a data set and then trained it on GPT-4. And LLMs are essentially just training on big text data. It's so massive you can't even fathom how big that data set is. And the whole point is to generate human-like language and perform tasks, right? We know this. We know LLMs can handle translation, we can do summarization and questions and answers, but it might lack in a lot of domain-specific knowledge. So how many of you guys have used ChatGPT and asked it to code in a really not popular language, maybe like Rust or something, and it just gets it wrong? Or maybe you code in TypeScript and it doesn't know a specific package exists, or you code in Python and the package is different from what the LLM knows versus what it is now, right? An LLM doesn't have current knowledge and it doesn't have domain-specific knowledge because LLMs are trained on general data, right? Like I said, the LLM is trained on the internet. The internet is this massive general data set. It has everything, right? It knows everything, but it doesn't know everything in depth, okay? So that is one specific problem about LLMs. Now, fine-tuning basically takes an LLM like ChatGPT and trains it on a specific type of domain. So what is a domain? Domain is like a topic, or it can be a very specific topic. So imagine you can have an AI that is trained specifically on how to write good movie scripts, or you have an AI that's trained specifically on how to put together IKEA chairs, or you have an AI model specifically trained on, whatever it is, right? These are domains like building chairs, or maybe building a computer, or building, or writing a code in this language, right? All these LLMs, if you fine tune it on specific domains, you give it a specialization. You give it the ability to answer in depth about that domain. Okay, so when we were fine tuning that model earlier about stock tool calling, we were training that model on tool calling for stock data, right? Very domain specific. And that's the whole point of fine tuning, is to give that domain specific knowledge to an LLM. And fine tuning also increases accuracy, the tone of what you want the answers to result in, and compliance, right? So there are AI models that exist in hospitals that are trained to be HIPAA compliant, that are trained to identify certain diseases, given some kind of, preset conditions. So specialization becomes really important, right? And this is exactly what fine tuning does. Okay. Does anyone have any questions so far? Okay. Good. So let's talk about fine tuning itself. So there are a couple of different ways to fine tune a model. Okay. One way is full model fine tuning. And what this essentially means is removing an entire model's knowledge and replacing it with another set of knowledge. Full model fine-tuning essentially makes the model completely dumb. It doesn't have any knowledge. It removes all of the knowledge and then replaces all of that knowledge with your own domain, right? Domain-specific knowledge. So for example, if I took GPT 4.1 and I removed all of its general knowledge and I put only chess moves, then all it is going to be able to give me is chess moves. That's it. It can't even speak English. It can only give me chess moves. Or if I take a model like GPT and I train it on how to build computers, then it won't be able to answer anything else other than computers. That's the only thing it will know. It does not know anything about the world. It doesn't know anything about the internet. All it knows is how to build a computer. So this is called full model fine-tuning. And this becomes really important in certain areas of business. So for example, this can be important in hospitals or compliant businesses. This could be very important in critical infrastructure where you only want an LLM to be concerned with a specific task, right? So if you want an LLM to be really good at just one task, full model fine-tuning is great. But the trade-off you make is now the model knows nothing else. It just knows that one thing. So sometimes you want it, sometimes you don't, right? Now, the second way that you can fine-tune a model is called parameter-efficient fine-tuning. Without going super in the details, an AI model has a certain number of parameters, and these parameters basically hold general knowledge of the world, like internet, like general people, anything, right? If you ask ChatGPT who Taylor Swift is, you're going to know who Taylor Swift is, right? Now, if you did a full model fine-tuning, then Taylor Swift might not even exist for that model. But parameter efficient fine-tuning doesn't remove all of the world knowledge. Instead, what it does is just removes part of it. So imagine you take a model like GPT, and the parameter you remove is how to build a computer and everything about IKEA, or everything about how to make chicken momo. And you replace all those parameters with your own domain-specific knowledge. So now what happens? This means you have a model that has most of the world knowledge, and you have a model that has domain-specific knowledge. So it's kind of best of both worlds. Now you might think that, but there comes some trade-offs with parameter-efficient fine-tuning. Number one, you don't have all of the general knowledge, and you can't exactly choose what to remove. So when you do parameter-efficient fine-tuning, you don't really know what data you're removing, because these parameters are all random. You could be removing some piece of history knowledge or some piece of code knowledge. You have no idea. So this is just general knowledge you're removing. You have no idea what it is. And you're replacing it with domain-specific knowledge. Now, the other trade-off is it's not going to be as accurate as full model fine-tuning. So for example, if I had a full model fine-tune of GPT on steps to make chicken momo, and I had a parameter efficient LLM with the same exact domain, the full model fine-tuning might be better with the exact recipe, but the parameter efficient model might be better because as general world knowledge, it can tell me more things other than just the recipe, right? So there are certain trade-offs that you have to consider when doing these methods. So you might have less accuracy, but you might have overall better knowledge of that domain. Whereas in full model fine-tuning, you remove all knowledge and you only have that specific knowledge. And parameter efficient fine-tuning happens with something called LoRA. It's a technique. It stands for low rank adaptation, and it just fine-tunes a subset of those parameters. A benefit of doing parameter efficient fine-tuning versus full model fine-tuning is that it takes less time to train. And this is kind of obvious, right? If I wanted to train an entire model on full model fine-tuning, that's going to take forever because I have to replace all of that knowledge with my own knowledge. Parameter efficient fine-tuning just replaces a small part. So of course, it saves time, it saves compute time and cost, and it saves money, right? Saves money. So those are some trade-offs and pros and cons. Now the third one is instruction tuning. So if you guys, have used local models before, you've probably seen versions of models called instruct. What this means is these models have been trained to follow a set of instructions better. So it's not necessarily how much of the model you're training, it's what you're training the model on, right? So when you fine tune a model, you could be fine tuning on how to answer a question or how to ask a question or how to respond, how to think. But instruction tuning is just how to follow a set of instructions, right? So this is kind of more specific. Let's say you want an LLM to be able to do a task, right? For example, I want to know the stock data set. I want to know the stock of today and tomorrow and previous, whatever it is. Then I can do instruction tuning, fine tune, right? And this lets me train the model on how to follow a set of instructions to do that task. So this is great if you want an LLM to do a certain task and you want it to do it really well. This is a really, really good way of fine tuning. And it doesn't remove a lot of the general knowledge. You're just changing the way it follows instruction. And the final way of fine tuning is domain adaptation. And this is kind of not really used all that much, but it's just basically fine tuning based on specific topics and fields. So not maybe just one, but maybe a couple, right? And you're giving it a wider view of domains and fine tuning it based on all those domains. So it's not as focused, but it gives a little bit more general knowledge of that domain. Okay? Any questions so far? I know this can be very confusing, so feel free to ask any questions that you have. Are we all good? Any questions at all?
We are good.
Okay, sounds great. Let's keep going. Now, let's talk about fine-tuning versus RAG. Can someone tell me what RAG is? I know you guys learned it last week and the week before. What does RAG mean and what does it do? Does anyone know? Someone tell me.
Retrieval augmented, what was the last one? I forgot that. But it retrieves let me remember.
Is grounding maybe?
It's retrieval augmented generation.
Generation, yeah.
So how does that work? Like high level overview, how does it work?
So it connects to different models, right?
Exactly, outside of the exact model, exact data.
Kind of. Can we be a little more specific?
Mostly um, large language model, it is based on some of the data set or some, if we do fine tuning or from internet. Besides that, RAG helps to get the information from other training data sources besides these. I think I understood that part.
So what about RAG means? My understanding is like RAG. So we have a grounded data. So we ask a prompt to give me the details about something Apple. Then it goes to that document, grounded document, and then gives that takes all those information about the Apple, and then now LLM it goes to the LLM, and then it gets better version of message and gives it back to us, I guess.
I think there is a model, and then when we with RAG, what we can do, I think, is it's gonna go beyond that model, right? It's not just limited to that model. It goes outside of model and tries to find similar information and gives us the result. I think that's what I.
Exactly, exactly. Like the
So
one AI is there, okay? nowadays it's so popular. Yeah, something it goes through the internet and give one specific answer. Possibility or something is there. Yeah, like that. It depends on a RAG. I'm not sure.
Okay. So you guys are kind of there. Not, I wouldn't say exactly. RAG uses a vector database to store chunks of text, and they're called embeddings. And these embeddings are essentially like lines on a graph. And if we want to know the context, let's say, of a document of Apple, we can ingest a document of Apple into chunks, and those chunks turn into lines on a graph called vectors or embeddings. And then we do some math to compare the difference between the user prompt and that text data. And whatever is closest, we get the top relevant results and then put it in a prompt. Okay. So RAG has nothing to do with training. It's just a way to get relevant information. Okay. So RAG has nothing to do with training. You don't have to train a model. All it does is take a user prompt and then check what kind of data is most relevant to answering that question using a vector database and their embeddings, and then returning a list of those embeddings back to the prompt of the model. And now the model is able to give a better answer because of that RAG. Okay. So RAG and fine tuning are very different. Where fine tuning, you're doing training of a model, you're training a model, right? On RAG, you don't need to train a model at all. So what are some use cases of fine tuning versus RAG? Number one is the knowledge. Now, how you guys have all used GPT, right? I'm sure when you use GPT and you asked it about today's stock price, I guess like a year before, it would not be able to tell you. It would say something like, oh, I only know knowledge of 2023 this day, October, right? Have you guys seen that before? It only has knowledge up to a specific date. Nowadays, that doesn't happen because we have better systems. But that the reason that would happen is because when you train a model, you have to train it on a data set, and you can't update that data set. So for example, let's say I trained a model on 2024 data, and now it's 2025. So if I asked a model about today's data, it wouldn't have anything because it only has 24 data, right? But the problem with fine tuning is I can't just take 2025 data and put it in 2024 data. That doesn't work. Basically, I have to retrain that entire model again in order for it to have up-to-date information. So the data that a model has from training and fine-tuning is static. It never changes unless you train the entire model again. Whereas with RAG, you don't have to train the model. All you have to do is update the knowledge source in your vector database, right? So it's dynamic, it's easy and fast to update the knowledge other than fine-tuning, right? Imagine every day you wanted to record the stock price, and every day you either had the choice to train a model again or you use RAG to ingest today's stock price. What do you think you're going to use? That's cheaper, that's faster, and easier to use. It's RAG. Because if you had to train a model over and over again every single day, that's super expensive, super slow, and the net benefit isn't all that much. Versus RAG, you just have to update the text in the vector database. And that's it, right? So that is a very big, uh, you know, a con or very big, like, what is it called? Negative of fine tuning is that you can't have up-to-date information. With just
Sanskar,
fine tuning, you can't.
so we can use live data as a knowledge for a fine tuning model, right?
So yes, you can. Like for example, so here's the reason why it doesn't work. Imagine I take GPT 4.1 and I get all the stock data from when the stock market opened back in the 1900s, I guess. I don't know when it opened, all the way to today, right? Let's say I take all that data and I train a model. Okay, let's say I train that model in a day, which would be impossible, but let's just say it happened in a day. Then when tomorrow comes, I have to train that entire model again. I can't just add that next day into the fine tune of the model. I can't do that. You would have to train that entire model again. And so it becomes really inefficient and costly, right? So when you train it once, maybe it's live for that day. But as soon as the next day happens, the next week, the next month, the next year, it's out of date, right? And you'd have to keep fine tuning over and over and over again. And so that becomes really expensive, right? Fine tuning is a very expensive operation as it has to happen on GPUs. And you have to have multiple GPUs in order to fine tune a model. So that's why I say fine tuning is not really a good example of having up to date information. Whereas, imagine we had RAG. Every day, we just take the current stock trend and put it in our RAG database. That is less than maybe a 5-minute operation at max. It's very efficient and it'll work with our model. Now, the model itself might be outdated, but we can just tell the model that we have up-to-date information. So when we use RAG, it can just judge it based on that data instead of its own training data. That's why RAG is really, really useful there. Make sense? Okay. Oh, Ashish, what's your question?
Yes. So vector database we can update, but is there a limitation? Like we can update for another 5 years, or we have to tune also, or like is there any limitation on updating the vector database? Like, can we update unlimited time, or what I'm saying is like
Yes.
after 10 years, 20 years, also we can update, or is there a limitation on the database itself?
So vector databases, in general, it would probably be very difficult to reach a limit. Now, of course, there are many different vector databases out, software-wise. There's Elasticsearch, there's Chroma database, there is PG Vector using Postgres. All of these different vector databases have their upsides and downsides, right? Some are faster, some can store more data. So it really depends on the type of vector database you're going to implement, right? So let's say I have Elasticsearch. That's a really good database for searching queries. Or if I have Postgres vector database, that's really good for sustainability, maintainability over long periods of time and a lot of data, right? So it depends on the vector database you choose. That's where it comes down to software decision and software, whatever you design your system with. But in general, you'll have to have a system to make sure you don't have old data, you just have new data, or maybe a specific period, right? Maybe you just want 5 years of data instead of the entire like 20, 50 years of data, right? That's kind of on you on how you want to do it. But in terms of a limit, I wouldn't know. But I'm sure the limit's really, really high. And it's unlikely you would hit that limit.
Okay, thank you.
Because I mean, yeah, it's just storing vectors, embeddings are really just a string of numbers in a matrix. So if we're just storing a matrix of numbers over and over and over again, maybe you'd run into some integer size limit down the road. Who knows? I really don't know. I can't really tell you, but that's something you can look into.
But
um
retrieval part might be like longer, yeah. Like if the vector database is used, retrieval means
it
getting
yeah,
the
yeah, it
data.
can. It can, but it depends on how you retrieve that data. So in RAG, simple RAG, you know, all you really do is you go through the list of vectors and then you do math. But that's really inefficient, right? There are different ways to do that retrieval process. So it's a little bit complicated. But if you want to look into how to, calculate distances, like so to find relatable information through embeddings, you use a function or you use a math equation called cosine similarity, math function. You can also use something like Euclidean distance, but they measure different things and they measure different types of relativity. Again, this is going a little bit far. You don't really need to know this stuff, but there are ways to retrieve those vectors in near constant time. And yes, with more vectors, there can be an increase in process time, but specific vector databases mitigate that, like Elasticsearch, or the way that you look for those vectors, you can optimize that as well. But typically, RAG is quite fast. It's never really like, like slow. I've worked at big enterprise companies with trillions of, PDFs ingested in vector database. But the result or the querying has always been really, really fast, within like 5-10 seconds max. So I wouldn't say it's that much of a bottleneck. But if you want to look into how those embeddings are chosen, that could be a really interesting like look into.
Okay, thank you.
Yeah. Okay. So the second thing about fine-tuning in RAG is latency. So this is where fine-tuning actually has an advantage. See, what happens when you fine-tune a model is you're replacing that general internet knowledge with a domain-specific knowledge, as well as you might not fill every parameter of that model, or you might have a very lightweight data set. So when you use fine-tuning, it's also, you don't need to go and access other systems. Like RAG, you have to access a vector database. You might have a network limitation, right? You might have network latency to go talk to the vector database, go retrieve the vectors and embeddings, and then get that data back to the client. There might be some latency. Fine tuning, you just query the model, and the model is extremely fast. If you're running on GPU, there will be minimal latency. There's no like major latency blocker that you might have with RAG, simply because there might be a network. You might have a set of systems for RAG. You might have to talk to many different services. So there might be higher latency versus fine tuning. You'll just be speaking to the model itself, which is very, very low latency because you're talking to the model itself. You're not talking to multiple different services. So latency is better with fine tuning. How much that matters for your application, that's where you determine, do I need RAG or do I need fine tuning, right? So a good example of this could be, you know let's say I'm an officer in the field and I need to know data about a specific, I don't know, police rule or amendment or some rule, something, right? If I have a model that's fine-tuned, I'm going to get that answer much faster, and I don't need to even rely on network, right? Depending on where the model is being served from. And for RAG, I would need to search through an entire vector database. You'd have to go and, call services. There's differences, right? I'm sure you get it. The third thing is cost. So fine tuning is a lot more expensive than RAG. And the reason is because of training the model, you need graphics cards. Graphics cards are very expensive. They take a lot of power. Your electricity bill goes up, and you might even have to pay another provider, right? So you could fine tune a model on AWS or Azure, like we're doing. You could train it on Lambda. You could train it on many different services, but they're all very expensive. Because essentially what we're doing is we're renting a GPU, saying, hey, Microsoft, take some money, train this model for me, and then give me the model back. I'll just pay the amount of GPU power I'm using from Azure. And so it can be really expensive, right? Now, the model we're training is not going to be expensive at all. It'll be very, very cheap. The data set's quite small. But you can imagine if you have a massive data set and a massive model, it can get really, really expensive. In fact, there's like a metric out there. Whenever a new GPT model is created, almost $1 billion is wiped from OpenAI because it costs so much money to train a model, just even once, right? So it's a very expensive process. Now, RAG isn't as expensive. All you would have to do is host a vector database. You would just need to handle network calls, and there's not much to it. You're not using GPUs, you're just hosting a vector database. And maybe you're hosting a couple of services, but the cost is much less, and you don't need to maintain it as hard as you would, have to pay for GPUs. So low upfront cost. And fine-tuning versus RAG, the best way to differentiate the two is fine-tuning is if you want really deep domain expertise, either to follow instructions, to know something about a topic really well, etc. And RAG is really good when you have a lot of data, it's live data, and it's unstructured data. So all of this factors makes RAG really good because it's not expensive to run, it's not expensive to update the information, and you can get dynamic information, right? And live information. So this is kind of where you would use one or the other. Now, you could use both, right? You could fine tune a model and use RAG, but it really depends on your use case and what you actually value. How many times are you going to fine tune a model per year, per month, per week, right? How long does that process take? What is the net benefit? There comes a lot of measuring performance of models when you do a fine tune and a RAG together, right? So you have to measure, is it worth the cost to fine tune a model and use RAG and do these other services? Or is it easier, cheaper to just do one of the things or to do just RAG or just fine tune? Depends on your use case, right? Ikesh, what's your question?
Yeah, I just want to ask, maybe it's not right, but if we say that a research agent in a Copilot, does that use fine-tuning model?
So research agent, it's a multitude of things, right? So Microsoft, I mean, I'm not totally sure how Microsoft did it, but if I had to imagine, it's probably an instruction fine-tuning, right? If you think about it, all these different agents do certain tasks, certain instructions. You can kind of see where they could probably use instruction fine-tuning to learn how to research or to learn to go deep into a topic, to learn to follow instructions, to do web searching, to look for live information. And there might be a RAG database to ingest all of the knowledge that it might be researching, right? So I would think that agent does both, right? And for Microsoft, it makes sense, right? They have the resources. They can use that cost to fine tune a research agent. Maybe they don't need to do it super often. And then they have the RAG in order to get relevant website information when they do the research. So I would think it's probably a combination of both. Yeah. Any questions on this? Does it make sense? Yeah, go ahead, Babu.
So, when's the best use of fine tuning versus RAG?
Yeah, so the best use of using fine-tune again is deep domain expertise. So imagine, actually, I've done a fine-tune project. My first ever AI project back in 2022, before GPT-3 even came out. I fine-tuned GPT-2. Actually, it was right after GPT-3 came out. GPT-2 became open source, I think with GPT 3.5. So this might have been 2023. I fine-tuned GPT-2 on my text behavior. So I sent my text messages to the model. I trained it on my text messages, the way I speak and the way I text. And GPT-2, it wasn't very strong, but it only knew how to text like me. So that's where it's important, is expertise on either following instructions or domain knowledge or following a certain behavior. It's when you need a model to do one thing really well, right? Either it's following instructions, either it's getting information by tool calling, either it's learning everything about the Java language or the Python language, right? A lot of you guys are, I'm assuming you guys know some tech, right? Coding agents are really popular right now. A lot of the coding agents are fine-tuned on really good code practices, right? So I'm sure if you've done coding in TypeScript, you notice some LLMs are better at TypeScript than other models, right? And that's because those models have been fine-tuned on best practice TypeScript than other models. I can say for sure that Claude Sonnet 4 does a better job with Swift than something like Grok. And that's probably because how much Swift knowledge was fine-tuned in Sonnet of Claude than Grok, right? So you can see the difference. It's how much knowledge they have of that domain. And RAG is really useful for when you have a lot of dynamic data, when you have a lot of unstructured data, when you have a lot of information that is hard to train on, but easy to give context to a model. So for example, if you wanted everyday stock price, everyday stock trend, if you wanted all this information, if you wanted, let's say you wanted a model or let's say you wanted a rag on all the tech news from last year to this year, and you put it all in a vector database, right? That's so much unstructured data. Each newsletter could be structured differently. It's hard to train a model that way. So RAG is really useful there. So a lot of dynamic, unstructured data, maybe like a lot of that stuff becomes really useful with RAG, and it's also very cheap to run in comparison of fine tuning, right? And of course they can be used both, right? They can be used um, together, right? And that's also very common. Okay, so let's move on. So I kind of went over this already, but there are some consumer and business use cases of fine tuning. So the first fine tuning consumer use case is consumer personalization. And this basically allows for AI assistants to match the tone of an individual, their style, and their language. And fine tuning does a really good job at this. Again, like what I mentioned, my first ever AI project was fine tuning GPT-2. And this is exactly the use case that I had, was to mimic the way that I text other people, right? So consumer personalization is really, really good. And you can see this in a lot of models today. Like you can see GPT speaks very differently comparatively to how Gemini speaks or how Claude speaks, right? They focus a lot of that on consumer personalization. Secondly, hobby bots. So AI specifically tailored for topics, niche interests, communities, etc. One of the first, I'll give you a little story here. The person that founded large language model, more specifically the transformer architecture, I forget his name, but he worked at Google. I think, oh, his name is Noah Shazier. I think that's his name. He came up with Transformers in 2017. Then he proceeded to leave Google because he knew how strong transformer and large language models were going to be. And um, one of the first companies alongside OpenAI to become like $1 billion company is Character.ai. Character.ai essentially has a model for each kind of character, and you want to talk to them. It's very simple concept, but the creator of LLMs created that company, and now it's a multi-billion-dollar company. So that was largely due to fine tuning, right? You can fine tune based on different topics, people, personalities, that kind of stuff. The third one, compliance in business. So business compliance, like what I was talking about in hospitals, they have HIPAA compliance. So the problem with just giving GPT-5 to a hospital is GPT-5 isn't perfect, right? It can't always be HIPAA compliant, right? There's many cases of a model stepping out of the zone of what you were asking for, right? So that's where fine tuning is really useful. So you could fine tune an entire model using HIPAA compliant data. And now that model is basically forced to be HIPAA compliant in the hospital scene, right? So there's a lot of compliance that fine tuning really helps with. And then enhanced customer support. So a lot of voice agents are fine-tuned on specific voices, specific sounds, and specific kinds of personalities for those kind of agents. So it really comes down to how a model behaves, right? Any questions on this? Okay. So we talked a little bit about cost as well, but we all know now the cost benefit analysis between fine-tuning and RAG. So fine tuning has a really high training cost, and inference basically just means like sending a query to a model and the model responding. So fine-tuning is really expensive in training, but it becomes really cheap once you're done training and you just have the model. The inference cost, or the actually using the agent, using the fine-tuned model, is really cheap because there's no other services that you need to consider, right? It's just you and the model. And so inference becomes extremely cheap. Again, with the downside of training being really expensive. Now, RAG is the opposite. For RAG, the training cost is low or basically nothing because you don't need to train a model, right? Or if you do train a model, you don't have to train it as heavily if you have a RAG and fine-tuned setup. But the inference costs can be much higher. And the reason is because you have to maintain other services, vector databases, maybe other microservices your system has. The costs can add up, and you might be paying a lot of cloud providers for those costs. So actually using the model might be more expensive than a fine-tuned model. Again, it's just a general analysis. In practice, it might be different, but in general, this is kind of what it looks like. So you have to acknowledge what are the trade-offs you're willing to make and what your application really needs. Okay. Now here's some implementation considerations. And I kind of touched on this earlier, but fine-tuning really, really depends on good data, right? A model, there's a saying that I like to use, is a model is only as good as it is the data that it was trained on. So if the data given to a model is poorly given or poorly written, or it's just poor data quality, then the model is also going to be a poor quality. That's just how it goes, right? A model is only as good as the data is. So unless you have good data, fine-tuning is not a good option. Okay, so data quality is very much a consideration. And there's also risk of fine-tuning. So when you fine-tune a model, you might come into the classic machine learning problems, stuff like overfitting, catastrophic forgetting, bias amplification. So what does that mean? Imagine you have a data set, right? Imagine you're trying to make a model that can tell from Democratic opinions and Republican opinions. What if your data set isn't equally 50-50? Let's say there's more Democratic opinion than Republican opinion. Now you're going to have bias in your data. You have bias in your data, and so your model will also have bias, right? So this is another risk of fine-tuning. You have to be very careful with the kind of data you provide for the application that you're looking for. So that is also a risk. There's also overfitting. Overfitting essentially just means, imagine you're training a model, you gave it all the answers, and you trained on only correct answers, right? So let's say I gave a model a bunch of math equations, and I also told them all the answers, and they were all correct, let's say. Then when a model looks at a math problem that hasn't been solved, it's going to get it wrong. And you might think that a model is doing really well, but it was only trained on correct answers. You need to have a split. When you train a model, you're going to have a set of data. Some is correct, some is wrong. And the model needs to train and figure out which is correct, which is wrong. So if you only gave it correct answer, or if you only give it wrong answer, it's not going to know anything, right? So those are some of the risks as well. Also, evaluation. So stuff like evaluating accuracy, the hallucination rate, user satisfaction, right? How much benefit are you getting from fine-tuning the model versus just using RAG? Or maybe not using anything at all, right? You need to evaluate all of these things as well. That comes in cost, that comes in a lot of time. So evaluating models is not very easy. It takes a long time to set up an evaluation pipeline. In most companies, it takes a long time to set up these systems, as well as constant monitoring. So if your models are going to be deployed in production, they are going to need constant monitoring to make sure that they don't perform something that you don't expect in behavior. And again, this goes all the way back to your data quality, right? So fine tuning is not so easy comparatively to just using RAG. There's a lot of different considerations that you need to, well, consider in order to have a good fine tune and then in order to for it to be effective, right? So that's a lot of information on what fine tuning really requires. Now, let's talk about some of the future stuff. So, where does fine tuning exist right now, and where is it really going? So, as I'm someone from this in the industry, I fine tune models pretty regularly, and I have a lot of experience, both in enterprise and individually. And I see a lot of, the most common fine tune that we see is parameter efficient fine tune. And that again means just removing part of general knowledge to put domain specific knowledge. It's actually very effective. And generally, it's easier to get a better accuracy score and less overfitting and less, um, you know, of the drawbacks with parameter efficient fine tuning. It's not perfect, but it is quite good. Comparatively. It's also much easier to conduct. Now, another thing, fine tuning only really happens with open source models. So a lot of the, there's two different sides to AI. There are closed models, like proprietary models, and open source models. An example of a closed model is something like GPT-5. You cannot train a model on GPT-5. You cannot train GPT-5. That is specifically prohibited, and OpenAI is not giving us access to train GPT-5. Whereas if we have an open source model, something like a lot of Chinese models like DeepSeek, Qwen, Kimi K2, Minimax, a lot of these open source models, you can do whatever you want. And generally speaking, open source models have gotten really good over the past couple years. In fact, some of them even rival the top dogs like Claude and GPT-5. Some of them are really, really, really good. But also running them is very expensive, and you're not going to be able to run them on consumer hardware. It's going to cost you thousands of dollars if you want to run it. So again, there are very, very difficult, barriers to entry to fine tune really great models. Now, the third point being there's a lot of regulatory, regulations happening not only in government but in AI companies as well. So a lot of AI companies are actually banning the use of, using another LLM to train or using another LLM to generate a training data set. There was I think a year or two ago, OpenAI had openly banned the use of ChatGPT to generate training data. And the reason is because other companies like Google and Anthropic were using GPT to generate training data. And there's a lot of legal battles happening in AI. So a lot of regulations that are happening in AI deployment as well, and ethical use. So AI can be fine-tuned for the wrong reasons. You might look at some military applications that you might see some misuse, or you might see it in other places. But there is, ethical use in AI. When you train a model, you're using GPU power, and it is not great for the environment. So there are some ethical issues as well. Okay. And to wrap things off, I know this has been kind of long, so hopefully once we're done with this, we can go take a look if our fine-tune finished. But some key takeaways is fine-tuning is really good if you want to increase a model's accuracy, consistency, speed, latency, basically everything. It can really improve it. But again, it comes with its trade-offs being expensive and, might take a lot of time. And with RAG, you might want to see what's worth using other than fine tune, or do you use RAG, or do you use none, or do you use both? When you use fine tune, you need to depend on a lot of factors like data quality, risk management, evaluation metrics, and a lot goes into a proper fine tune of model. And that also goes in with how many engineers you need to properly fine-tune a model, as well as ethical and emerging trends of fine-tuning AI and the impacts of it on our environment and the world. So that's kind of what fine-tuning is all about. Hopefully that gave you a good understanding of what it is and why we do it. Does anyone have any questions? Okay, seems like everyone got it. So let's take a look at that fine-tune model we were training. Oh, perfect. So mine is done. Is everyone else's done yet? So if it says the status is completed, then you know it's complete. It's finished fine-tuning. So give me a thumbs up if your model has finished.
Mine is running.
Yeah, mine's running
Running?
too.
Running?
Mine
Okay,
too
so a couple
running.
people. Okay, that's fine. So here's what we'll do. I'm going to showcase what a fine-tune looks like. So you guys will do this afterwards, and then we're going to have a classwork activity that I want you guys to do. But let's quickly take a look at what happens when we do a fine tune, right? So this is completed. So what I'm going to do is I'm going to click use this model. And we're going to need to deploy this model. So give it a couple seconds here. Okay. So we have global deployment, tokens per minute, rate limit, all this stuff. I wonder if we can also use it in our playground. So let's see if I go to agents here. Okay, so it's not here quite yet. If I go to playground, let me see if it pops up here. No, not yet. So I'm going to deploy it first. So let me go back. And let's deploy this model. Okay. So here we go. We have content filter. I'll just keep it to default v2. We're going to not touch any of this. Everything should be good here. And for the deployment name, I'm just going to call this stock agent. For me, I'm going to call it 2 because I have a second one. But here we go. It's going to be deployed. And there we go. It's being created now, so we're going to have to wait a little bit. If you notice in this little screen, we actually have a URI endpoint as well as an API key. So now that I've fine-tuned this model, I can actually utilize it in code in my own application. And we're actually going to take a look at that. I have a code example already set up, and we're going to see if we can use it to basically talk to this agent that we fine-tune. And if we have enough time, then we're going to see if everyone can get it set up as well. Okay, so let's wait a couple minutes here. Okay, anyone confused so far? Any questions at all? Is it kind of straightforward? Okay. Let's see if this is done yet. It's still going. So later, once we look at this stock agent, I'm going to have you guys create your own data set and then train a model on that data set as well. And you guys will be doing that in groups, kind of in like breakout room style, like you guys did last week. So we're going to go over how to do that as well. And then we'll do it. So we're going to wait for this. Takes a bit of time. Does anyone not have GitHub set up? Do you guys have GitHub set up or no?
GitHub? No,
No.
we
No.
don't.
Okay. Yeah, I know. Okay. So yeah, I have code. I want you guys to run it, but we're gonna see if it's possible. Okay.
So mine's
Oh,
complete this one, so I'm gonna deploy as well side by side
Mine
together
is
with you.
go ahead.
complete too. Yeah.
Yeah, go ahead and deploy it, guys. Go ahead and deploy it. Okay, so mine is finished provisioning. So what I'm gonna do is I'm gonna open this in the playground.
What is the deploy button or something?
Yeah, so if you go to fine tune, you click on this and then you click use this model and it's gonna let you deploy it. Okay.
Okay.
So here, once you've deployed your model, you're gonna see the agent that you created. Again, you gave it a name. I called it stock agent 2.
Mhm.
So for this, I'm going to actually generate a system prompt here. So this is a fine-tuned model on tool calling for stock trading, for stock information, I think. Its task is to tool call for stock information. Let's see. Let's generate a system prompt. Okay, here we go. Okay, it's too big. Let me see. Uh, let me try. Okay, it might be too long. Let me apply changes. Nope. Why can't I apply changes? Let me go here. Apply. Okay. So let me try a user query. Examples. Oh, you can set examples. Okay. Yeah. We don't need to do that yet. Also here, I don't know if you guys went over this, but there are a couple parameters you can change. You can also add your own data source if you want. So let's ask, tell me stock price or something. Let me see, stock data of previous, let me see, stock data of Apple from 2024, or let me see if it could do this. Here we go. Yeah. So this is kind of expected here. So we fine-tuned the model on tool calling. I don't know if we went over tool calling yet, but tool calling essentially, it tells them, it, makes the model generate tool, and then we call it. It's used in MCP servers in order to like get information. So the answers it's going to give us is going to be in tools. So when we have a tool like this, we have type, symbol, company, and date range. This is completely trained on tool calls. So this is more specifically for doing a task, right? And that's like calling a specific amount of tools or whatever kind of tools they need to call. So we know this based on the fine tune. If we look at the fine tune, we gave it a stock tool calling sample, right? The training data set. Let's see if we can download that training file. So here we go. I want to take a look at this. Oh, can I not open this? Let me see if I can open it in. Can I open this in TextMate? Let's see. Maybe, maybe not. Okay, here we go. Okay, let me change my screen share so you guys can see this. Give me 1 second. Let me reshare my screen. Second. Okay. So you guys see this? This is the stock tool calling sample data set. And we can see exactly what kind of data this was trained on. So it's essentially a list of messages. And you can see right around here, we have tool calls. And each tool call has a type, a function, a name, some arguments, and we can see the period here. So it's trained on tool calls. It's not trained on just generating text, right? The other option we have for fine tuning that we saw previously was on grade school math. That one probably is just for solving grade school math equations. This one is specifically for generating tools, right? And so if we look at this training data set, we can see a bunch of stuff like maybe can I make this JSON formatted? Let me see. Maybe I can do it this way. No, I don't think so. Let me see if I can make this look a little prettier. So okay, name, messages. Okay, so let me do this. No, not that one. Yeah, so like this is one part of this part here. So this is one big example of a tool call. So you can see anytime we have tools, it's generating a tool for that specific description of the prompt. So this entire model is trained on these tool calls, right? It's fine-tuned on tool calls. And that's very useful if we want to have a model to be able to generate a specific kind of tool so we can use it in a system. Again, we can train it on our own data set as well. We don't need to do it on tool calls. We can do it on text. We can do it on math, whatever we want it to be. Okay, so were you guys able to try it out?
So after the deployment was successful, I went to Playgrounds, but it's asking me to add a project to build with agents.
Yeah, you will need a project. So you can create one inside of your resource group. Also, if you notice here, this tool call we generated for Apple, look at our response. It says the current stock price of Apple is 173. Now, I don't know if that's true. Let's see. Apple stock price. No, right now it's 272. So it didn't get it correct, but it was able to at least generate it. Maybe we can pull this into a system in order for it to actually be accurate. But that's quite interesting. So there we go. Okay. So go ahead and try that. I'll give you guys about 5 minutes. Please use your stock agent in your chat playground. I will post this system prompt in the chat if you guys want to use this. This is a quite good one. So I will post this here.
Can you show your screen? Because I want to follow
Yeah.
that. Oh,
I put the system prompt in the Teams chat. So you can go ahead and copy it and then use it. And then try choosing the chat and see what kind of tool it's going to create and then the response.
so once
Okay.
you go to Playgrounds, you have to click New Agents, right? And then
If you go to Playgrounds, you're going to click on Deployment, and then you should see your agent here if you deployed it.
do you mind sharing my screen?
Yeah, go ahead.
Yeah.
Yeah, so go to fine tuning. Yeah, down there. So we already created this. Status completed. Click on use this model underneath details.
Oh,
Yeah, so here we
I
go. Now you can deploy it.
think I
So
already did.
you did
I
this? Okay, so cancel
yeah.
this. Cancel.
Oh,
Oh, oh well.
okay. Oh, it's gonna take some time now.
Now, if it's already deployed, then it should just take you to it. Okay, so it's still creating. So give it some time. It's still creating right now. You see provisioning state down there?
Yeah, yeah.
Yeah, so it's still creating until it sees succeeded. Once it says succeeded, then you can access that model. Okay.
Let me refresh this. What was that again? No.
Playgrounds. Try the chat playground. Here we go. So deployment. If you click on the deployment tab, no, not that one, not that one, not that one, the one right underneath it. Deployment, right underneath. No, 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 not that. That one, yes. So do you see? Okay, so yeah, your stock agent's already there. So you can use that.
Oh, I
So it
see.
seems like you deployed it twice. That's okay. Now copy the system prompt I put in the chat, and then you can use that in the model instructions, okay? Yeah, I'll give you guys about 3 minutes. Go ahead and try this. And then we're gonna move on to the classwork activity.
Which one are you talking about?
The one in the chat, the meeting chat.
Key instruction, right?
What? Yeah, that one.
I got to put it here, right?
Yeah, and then apply changes.
Yeah.
Apply changes.
So how do you know it's done?
Yeah, so it should be done now. You can try.
Okay. Okay.
Manjari, do you have a question?
Yep, my model is still queued. It's not completed yet.
Oh, well, that took a while, huh?
Yeah, I don't know
Um,
why.
okay. Seems like you might have to wait a little bit longer then.
Mine too running.
It's still running?
Yes.
Okay. Yeah, it's gonna take a bit of time. So this is why I said it's gonna take over an hour. So it's normal. Okay. So let's do this. Let's do a quick 5-minute break. And when we come back, I'll have you guys work on a classwork together where you're going to train your own model on your own data set together. And then we'll see if we can run it in code. All
So,
right?
Sanskar, so for your class four, what kind of data set we are making, like Excel, JSON, or what kind of format?
We're going to talk about it when we're back.
Okay.
Yeah. Okay. 5-minute break. Okay, welcome back, everyone. So let's continue. And what we're going to do is we're going to generate a data set and fine tune our own LLM. Okay, so here we go. Let me share my screen in just a second. So give me a second here. Okay, I think it's this one. Okay. So we're going to fine tune our own LLM as well. So the way we can do that, basically what I mean is I want everyone to generate their own data set of whatever task or topic you want it to be on, but it needs to be a data set for a model to be able to train on. And then we're going to use that model in code. So if we look at fine-tuning a model, of course, we need to choose a base model. I'm going to keep using 4.1 nano because it's the easiest. And in here, when we selected add training data, we can add our own data set. Okay. So we don't need to use the curated sample data set. We can use our own data set. Okay. Now, in order to generate a data set, you can read here very clearly that we need to ensure our training data is in a .jsonl file and it's formatted for chat completions with messages as a row header. There's also an example of creating data sets in this link. So let's quickly take a look here. So here is an example of a training data set. Okay, so it needs to be in this kind of style. So we need to have a messages, a role system, a role content, and then another answer, right? And we essentially want to train on this kind of data, this type of structure of data. Okay. So the way to generate a data set is very simple. All we need to do is go to some kind of provider. Let's say Grok. I'm going to use Grok, and let's see if this will work. Don't need to sign in. And what I want to tell Grok is, okay, I need to create a small data set for training GPT, training a LLM. I want to, or let's say for fine tuning an LLM, I want to fine tune on the topic of, and then let's say we want a topic, right? So I'm going to grab a topic from the classwork here. So I'm going to say email tone adjuster. Okay. The data set needs to be in this format. And I'm going to put the data set one entry. So I'm going to grab this here. Just watch for now, and then you guys can recreate this later. So I'm going to go back here, and I told this model that I need the data set to be in this format with the messages as the header. Right? Or I can just say with this format. So I need to create a small data set for fine-tuning LLM. I want to fine-tune on the topic of email tone adjuster, rewrites emails to be more professional, casual, and empathetic. Data set needs to be in this format. Okay, so let's try this. In this format and in a .jsonl file. Okay.
What about the validation data set? It's in the same format?
Yes, and we will do that in the next prompt. So I'm going to tell Grok to do this. So let's see if we can do this now. So This is quite common for LLMs. You can use it to generate a data set like this. So it's going to keep going here. And as you can see, it's in that format that we want it to be in. Okay, it might take some time. Let's see how much it generates. Now, okay, here we go. So it didn't generate that much. I didn't want it to generate too much anyway, so it's fine. So I'm going to copy this and let's say return this in a .jsonl format. Here we go. So now it's giving us in JSON. What we'll do is once it's finished generating, we're going to take this data, download it, and save it to a file. Okay, so there we go. There's a small data set here. So what I'm going to do is download this file. So how can I do that? Let's see. I might have to write this to a file. So let's copy this. And what I'll do, I'm going to close this. So don't save. I'm going to create a new file, paste, and I'm going to save this as email train data. Okay. I'm going to save this in my downloads. And now I will say create a validation data set in the same format and return it in .jsonl format. So create a validation data set for this training data set. Okay. So there we go. It should be creating the validation data set. So again, you need to create a training data set and a validation data set. The requirements, it has to be in this format, and it has to be exactly like this format. And it needs to be in a JSON type object or file. Okay. Here we go. So now we can take this and do the exact same thing. Take it here, save this as email validation data. And oh, I can save this as JSONL. There we go. Okay, perfect. Actually, I think I need to save the other one as JSONL as well. So, oh yeah, here we go. So that was a mistake here. Let's save this as JSONL. Okay, so once I have both, I'm going to go back to the fine tune, and I'm going to select existing files, upload files. And we're going to upload the training data set here. So, oh, it's not letting me. Let's try that again. Okay, maybe I need to go back into that file and save it. So JSON, okay, yeah, because it didn't actually save in that file. So let me do, okay, an easiest way to do this, I'm just going to take that and paste it here. I'm going to do this again. So email train data. Instead of .txt, I want to save it as .jsonl. Okay, there we go. So it's this one I just saved, so I'm going to remove this one. Okay. Oh, no, not that. Did downloads. There we go. Remove this. Okay. Upload file. Now we can select it. And we can see the preview. And now let's apply. And then what we're going to do is we're going to add the validation data, do the exact same thing, but now we're going to upload the validation data. Okay. There we go. That's what the preview looks like. And then we're going to hit apply. And for suffix, I'm going to call this email format fine tune. I don't know, whatever, right? And once we have the training data and the validation data, we can hit submit and we can start training on this data set. So this is your task. Your task, and I will share my screen one more time. Give me a second. Okay, if you guys go to the homework and assignments tab, I posted a classwork here, and it basically gives a bunch of examples of fine-tuning topics. You are free to choose one of these 10. I think all of these, just pick one of them and generate a training and validation data and train a model. Okay? You must make sure that it is in that format I was showing you, the JSON-L format. And I'm going to also give you the that GitHub link that has the format that it needs to be in, so you guys can use that. So I'll put that in the chat there. And just train a model based on your generated data set, or fine tune a model based on your generated data set. Okay. Any questions? Subodh, what's your question?
Sir, I'm really sorry, but I think it should be homework rather than classwork. I missed a lot of things here in between. I'm not in the same page as you are right now.
Okay, that's fine. I don't expect you guys to finish this for classwork. So for homework, it is also fine.
Okay.
But I want you guys to take some time during class to do this now. And
Sure.
then for homework, you guys can, try it and continue and see that. Okay.
One more question, if I may.
Sure.
Seems like we're just scratching the surface, right? So, I mean, watching all these things is like totally new kind of thing for all of us. Do you mind sharing, like, uh, who does all this back end work, like, building all these things? Do you mind if you have anything for us, building all these things?
What do you mean exactly? I'm
Like,
struggling to understand.
no, I mean, if I see my screen, Azure AI Foundry, and all these things, how long did it take for any person to, or any group to build up all these things,
Like learning all of this?
learning and developing all this screen in front of us to use it?
Can you give me an example, or are you saying how I learned to fine tune a
No, no,
model
no, no, no. I'm
specifically?
not talking about it.
I think what kind of job title actually does this work that you just showed us? What is the job
Okay.
title? Yeah, I think that is the question.
Okay. Yeah. So it can be many. Typically, they're called machine learning engineer or AI engineer. It can also be a systems part of, it can be AI systems engineer, but typically it's part of like machine learning title. Um, Now, may your job require you to fine tune a model? I cannot tell you, but it is a good skill to learn how to fine tune a model and how it works in order to understand the impact of such a technique. Does that help answer your question? So
Oh, yeah.
okay, yeah. So this is quite deep stuff. I know that this might not be, quite digestible as maybe our previous learnings in Copilot Studio. But as we said before, this is Foundry. So this is quite going to be some low level stuff. We're going to be talking about quite advanced topics. Now, we're not expecting you to understand all of it, but as long as you can have a general idea of what is happening and what it's doing, then that is really, really good. Again, you're not expected to learn all of the nitty gritty stuff. You're just expected to learn the business value and as well as how to do it yourself. All right, so how to set up a fine tune, how to generate a data set in order to fine tune a model. That's an actual skill, like you can actually use. But in terms of knowing, the very specific systems and data pipeline, like all of that, you don't really, it's not very expected of. Okay. Ikesh, what's your question?
Can I share my screen? Because I'm trying to deploy, but it's still on the status queue. But even I highlight that one, I not able to deploy it. So let me share my
Okay,
screen.
go ahead.
So I'm here right now. So this is the new one I built.
Okay.
So it's queued. Even I select this, it's not working to deploy.
Yeah, it hasn't finished at all. It hasn't even started training yet. But the first one has finished. So is this second one a custom data set or
Yeah, this is the custom one. I just made a travel agent one with like 25,000 records on each one.
okay? Was it in the format
Oh yeah,
that okay. Then yeah, it's gonna take some time to
yeah.
fine
This
tune
is the
off.
one I did with the message and content in this one.
Okay. Yeah, so this is gonna take some time in order for it to fully train. So that's good. I'm gonna have everyone do the same exercise. And then when we're back, we're gonna look over how to utilize our model and code. Is
So
that
this will
cool?
take like a couple hours time, like earlier.
It might take a couple hours.
All right.
Yes. Yeah. So I want everyone, I'm gonna give you guys about 20 to 30 minutes. I want you guys to look through the classwork, pick a fine-tuned topic, and I want you to generate a data set, both the training data set and the validation data set, and train your own model. If you want, I'm going to also leave the prompt that I used to generate the training data set. Okay. So you guys can perhaps use that as a guide. Any questions?
Can we do it in a group?
Yeah, I'll separate you guys in breakout rooms. Give me 1 second. Okay, give me 1 second here. Not seeing a breakout room option. Why is that the case? Okay. For some reason, I don't have access to put everyone in a breakout room. In that case, you guys can um, try it on your own, or if you want to collaborate with someone, uh, I don't know. You guys can just talk in this call if that's fine. I don't have permission to create breakout rooms, so I can't really do that here.
We can go as a collaborate, maybe.
Sorry?
We can go as a collaborate. So
Yeah. If you guys want, I'll give you guys till 7:30 PST, so about 35 minutes. Or if you guys finish early, then we can move on. So up till 7:35. But if everyone finishes early, then we'll move on. If you guys want, you guys can work with each other in the chat, or you're free to create groups on your own and call each other and then come back to the room when you're finished. I'll leave that up to you guys, but I'm gonna give you some time. Let me know how it goes, and then once you have finished training, or not finished training, but once you have finished submitting your model for training, then come back to this room, or just show me that you have the model training. Then once everyone has done that, then we'll move on. Does that sound good with everyone?
Yep.
Okay. I'll give you guys about 20 minutes. And then if we finish early, we're going to go over some code. Okay. and I'll be here if you guys have any questions.
Not sure how to start.
Why
Uh,
don't one
uh,
of us share the screen and start like chatting and someone
Yeah,
will.
one of us. Why don't
Yeah.
we? Yeah, one of us share the screen and then we can go through that while others can follow that.
Yeah, that
Yeah,
would be a
go for it.
good idea.
Okay, I can go ahead.
Yeah.
यो चाहिँ मेरो so we are all in one group, right? All of
Yes.
us.
Yeah, yeah.
Okay, yeah. Okay.
I think
Yes,
you
but
have to.
also make sure you're training the model on your own as well. Okay. So if you can work together, but I want everyone to train their own model as well.
Right.
So
I
help
think
each other.
yeah, we need to look into the question first. Which one you're gonna pick up? Subhaji,
मैले टेस्ट
Yeah,
हेरेँ
हजुर
कि मलाई
हजुर यहाँ छ क्वेसन
होमवर्कमा होला यो होमवर्क सेक्सनमा कि
अशोकजीको म्युट गर्नु पर्ला ब्याकवर्ड कसको आवाज
के सिङ्गाको
अनि मेरोमा कसरी आवाज आएको छैन
सुबोधजी तपाईँले त्यो होमवर्कमा उ गर्नु न एकचोटि त्यहाँ क्लिक गर्नु त हो
generate data set and fine tune your own LLM हैन ठिकै छ
संस्कारले दिएको प्रम्प्ट युज गरेर कुनै एउटा पिक गरौँ हामी यहाँ आउट अफ 1 to
एउटा
10
कुनै पिक पिक
पिक गरेर डेटा
गरौँ
सेट
त हामी
बनाउँ
एउटा कुन चाहिँ हाम्रो लागि अब हुन्छ नि सबैजनाको
होइन इन्डिभिजुअली गर्ने भने गर्न त एकजनाले चाहिँ त्यहाँ
Yeah,
गर्ने
just
अरूले चाहिँ
choose
कपी
your
गर्ने
own.
सबैको स्क्रिन हेरेर अनि हामी सबैले फलो गर्छ नि बाकीले अहिले
ए।
सबैले पिचिङ गर्दै गरौँ
ए,
तपाईँ एउटा पिक गर्नु त आउट अफ 1 to 10
ल एउटा रेसिपी एडाप्टर त्यो अलि ओके लेट मी चुज रेसिपी एडाप्टर सबभन्दा सजिलो यही होला जस्तो converts recipes between dietary and ओके ल ल सबैजना फलो गरौँ अब कसले के चुज गर्नुभयो होइन मैले त्यही अब फुडको युज गरेँ
अब पहिला को पाइलटमा पहिला डेटा बनाउँ होला अब सुरु गर्नु होला हामीलाई फाइल चाहिन्छ फेरि
फाइल डेटा फाइल होइन यी केस चाहिँ त्यही उसको के अरे
डेटा क्रिएट गर्ने
ट्रेनिङ डेटा र अनि भ्यालिडेसन डेटा
त्यो संस्कारको प्रम्प्ट युज गरौँ त्यसमा अनि तपाईँको त्यो अहिलेको कुन रोलको भन्नुभएको छ त्यो अलिकति ट्विक गरौँ न त्यसले डेटा जेनेरेट गर्छ नि यो नम्बर 4 पुरै कपी गरिदिनु त्यो रेसिपी एडाप्टर र अरू के छ
यो होइन प्रम्प्ट
प्रम्प्ट तलको त्यो ग्रक प्रम्प्ट
ग्रकमा मैले ग्रक चाहिँ चलाएको छैन
Now,
अहिलेसम्म होइन
त्यसमा गरौँ हुन्छ को पाइलटमै
I'm
गरौँ
just gonna give you one quick warning. The prompt has the dataset format. You might want to change it based on what you're using. Okay, so whatever dataset you're training on. Actually, the format should be fine. Not, disregard that. That should be fine. Um, just make sure you change the topic to whatever topic you're going to fine tune for.
सुबोधजी
So,
त्यो डेटा सेट 4 पछि चाहिँ तपाईँको त्यो राख्नु है रोल के हामीले के को गर्नु लाग्थ्यो तपाईँले है
न मैले अघि यो फुडकोमा राखेको रेसिपी
त्यो पुरा कपी गर्ने अनि त्यस्तै त्यही किसिमको डेटा दिन्छ नि अनि डेटा सेट 4 पछि राख्दिनु फर्स्ट लाइनमा फर्स्ट लाइनमा डेटा सेट 4 पछि राख्दिनु
हैन
त्यो नकाट्नु त्यो राख्नु अनि त्यो ठिकै छ बुझिहाल्छ नि
इमेलको त यसमा त इमेलको हुँदैन होला नि त हैन I want to fine tune on the topic of email tone.
त्यसमा त्यो पनि निकालिदिनु हाम्रो डेटा सेट त्यतिकै बनोस् त्यो फर्मेट मात्र हो क्या तलको
यो फर्मेट मात्रै हो तर यो मैले कपी गरेको कहाँ हाल्ने र मेरो डेटा
त्यो स्मल डेटा सेट पछि हाल्दिनु
No, you want to hold on. You guys need to be very careful here. Be very careful with your prompt. So I want to fine tune on the topic of email tone adjuster. Is that your topic or no?
No.
That's what I was
Then
saying.
you want to remove it, right? You want to remove it. That's not your topic.
Where is it actually? Which line?
What did you copy? I don't know.
Food. Something. Yeah.
Okay, then you should replace it, right?
Oh, yeah.
Otherwise, you're going to get bad data. Remember,
mine
your
is
data-
a recipe adapter. Yeah, this one.
Yeah, so you want to replace the email tone adjuster with that. So make sure you get a proper response.
Remove email tone adjuster. Second line.
Yeah.
पुरै निकालिदिनु होला इमेल टोन पनि सबै
Email tone बाट सुरु गर्नु
Paste.
Yeah, remove it. Delete. Okay, now paste.
Is it good, Sanskar?
What do you guys think?
I need to create a small data for fine tuning, and then I want to fine tune on the topic of recipe adapter conversation between. I think you should put that
content
after adapter. That converts recipes between dietary restrictions, right?
त्यो ननिकाल्नु होला त्यो त फर्मेट हामीले स्याम्पल यस्तो स्याम्पलबाट बनाइदिनु भनेर राखेको छ नि हैन
You don't have to do anything on that part, I think. Oh, no. Because it's showing messages. Why would we keep messages if this is a completely different
No, that's the format त्यही थियो नि त हैन बाबुजी है त्यो स्याम्पल देखाउँदाखेरि
But that was email one.
I think this should be good.
Email को थियो नि त हैन email को भएर चाहिँ मेसेजमा यो रोल यो भयो हैन user को reply users question accurately as possible.
So go look at the fine tuning model data set, the sample data set I put in the Teams chat. So it needs to be in that format. So go in the Teams chat and look at that GitHub link I posted. It's going to be in that format and needs to be in that format, regardless of the topic. So go to the Azure AI Foundry.
ए मेसेज भन्ने नि छ बाबुजी त्यसमा पनि फर्मेटमा
Okay. Oh, okay.
त्यो जेसनको फर्मेट भएको र यस्तो भयो होला कन्टेन्ट रोल सर्भिस
Yeah, I believe you use it to copy. That was a bit too
No. You already, this is already part of the chat. So this is just me showing you. Yeah, this is just, I'm just showing you it needs to be in this kind of format.
Okay.
regardless of topic.
Mhm. So hit it.
इन्टर गरिदिनु हेरौँ कस्तो जेनेरेट गर्छ
Yeah, just 2 lines for now so far.
केसी तपाईँले अघि डेटा सेट क्रिएट गर्दाखेरि के प्रम्प्टमा त्यही सिम्पली त्यो मात्रै चेन्ज गर्नुभयो हो टपिक
मैले
मात्रै
मैले त आफ्नै युज गरेको थिएँ पक्नु है म मेरो राख्छु
मेरोमा पनि त्यो फर्मेटमा आएन
मैले
मैले यो
म च्याटमा
फाइनल्स
मैले चाहिँ नि ग्रक युज गरेको थिएँ नि मैले त्यही कोपाइलट युज गरेँ
मैले पनि को पाइलट नै युज गरेको तर
मैले चाहिँ यसरी पठाएको मैले भर्खर ग्रुप च्याटमा पठाएको थिएँ
Sanskar, hope you understand Nepali as well.
म नेपाली बोल्छु त सबै बुझ्छु
Okay, cool.
तर मेरो नेपाली जस्तो राम्रो छैन म बुझ्छु सबै
That's fine.
मैले चाहिँ च्याटमा हालिदिएको छु मैले चाहिँ त्यसरी युज गरेको थिएँ तर मेरो चाहिँ धेरै रेकर्ड भएको टाइम लागिरहेको छ जस्तो
So why is taking so long? It's been generating just 2 messages.
yeah I would say try different models so someone use Gemini maybe you want to try chat or Gemini or something use the same prompt on a different model it doesn't matter the model I just use Grok as an example
Okay.
should we give like number of records then probably it will generate
yeah you can do that too it's your prompt you do what you think is going to work
so it's have you used Claude for coding
yes
what about the black box AI
I've never heard of that one
okay
Oh,
What is the difference between training data and validation data?
training data isn't always correct meaning in training data, it's best to have a question and answer, but the answer does not need to be correct. The validation is essentially like an answer sheet. So it contains all of the same questions, or maybe different questions, but with correct answers. It's meant to teach a model what is right and what is wrong.
Okay. So I heard something like for a given data set, use 0.1% for the training. So that is same logic here also, something like that.
Yeah. So in traditional machine learning as well as LLM, when you do like fine tune a model in code, you typically want the training data set to be around 50 to 80%, and the last 20 to 40% should be the validation data set. It it depends on what kind of data you're training, but there's always a split, a training data set and a testing data set.
Okay. Thank you.
I think we are some kind of stuck here. Grok is still thinking. ChatGPT, I don't know, it gave us like 6 examples.
So maybe try adjusting the prompt to see if you can get a better answer. This is a very much a prompt task as well. You should be
Yeah.
able to write a good prompt.
Okay, let me paste it. To Grok. So I don't know, if you don't log in, how many prompts it allows you. I don't know. But let's try. You want me to give it to a researcher? It's gonna take some time, but yeah.
तपाईँको डेटा सेट पढ्न टाइम लाग्छ जस्तो
Oh,
म सेयर गरौँ त मैले दुईवटा डेटा सेट त बनाएँ होइन
एनएसले चाहिँ अलिक टाइम लाउँछ होइन?
अरू कसैको छ भने सेयर गर्नुभयो नि हुन्छ
होइन, हजुरको सेयर गर्नु ल।
एकैछिन मलाई गाइड गर्नु है त मैले त्यो डेटाको पार्टमा चाहिँ आई मे मेरो डेटा सेट चाहिँ मोडल ट्रेनिङ मैले ट्रेनिङ गराएँ होइन यही त हो नि होइन यसमै त हो नि नेक्स्ट वान भ्यालिडेसनको भयो
तपाईँले कहाँबाट ल्याउनु भयो अरे त्यो?
मेरो त कोपाइलटबाटै निकालेको हो
ए,
यसले 50 डेटा सेटको चाहिँ ट्रेनिङ डेटा सेट बनाए 10 अहिले चाहिँ नम्बर अफ डेटा सेटतिर भन्दा पनि अब यसलाई गर्नु पर्यो चाहिँ हामी फाइन ट्युनमा गएर फाइन ट्युन मोडल गर्नु पर्यो होइन त्यसपछि जिपिटी 4.1 न्यानो गरेको थियो अनि नेक्स्ट गर्नु पर्यो सुपरभाइज नै हो हाम्रो अनि त्यसपछि त्यो भइहाल्यो हो यहाँनिर चाहिँ हामीले 8 ट्रेनिङ डेटा गर्ने हो नि केसी
हजुर हजुर
है यसलाई चाहिँ create data samples
आफ्नै फाइल अपलोड गर्नु
existing file
अपलोड
no upload upload file यसको डाउनलोडमा गएर ट्रेनिङ डेटा स्किप भने सिस्टम रो डाटा अप्लाई गर्थ्यौँ होइन अप्लाई गर्थ्यौँ त्यसपछि के भयो हजुर
भ्यालिडेसन डेटा पनि एड गर्नु
भ्यालिडेसनको चाहिँ choose a date
त्यो ड्रप डाउनमा क्लिक गर्नु न आउँछ
upload file validation say script preview so त्यो भयो
सफिक्समा नाम दिनु
चाहिँ यो के पो थियो यार फाइनेन्सवाला थियो यो फाइनेन्स एनालिस्ट के गर्नुपर्ने छैन है यहाँनिर सब गरिदियो यो क्युमा हुँदा अरू कसैले डेटा बनाउनु भएको छ भने सेयर गर्नुभयो हुन्छ है के बेलामा चाहिँ अब फेरि त्यतातिर गरिदिइहालौँ त्यो क्युमा बस्छ अनि मेरो त्यो बिचमा चाहिँ यो सक्सेसफुल भइहाल्यो भने फेरि ब्याक टु म सेयर गर्छु
तपाईँको चाँडै हुन्छ होला सानो सेट भएकोले मेरो
डेटा सेट त सानो
धेरै भएर टाइम लाग्यो
सानो भयो भने टाइम त लाग्छ जस्तो मेरो मेरो सिस्टम स्लो भए नि हुनसक्छ कसैको डेटा सेट बनेको छैन भने लेट्स ट्राई है अब यो रन भइराख्दाखेरि टाइम लाग्छ जस्तो यसमा सुगरजी तपाईँ सेयर गर्नु नि त यो म हेरिराख्छु अनि यो सक्सेसफुल भएपछि फेरि म सेयर गरौँला डेटा बनाउनु त सिक्नु पऱ्यो नि
हजुर मैले त केही गरेकै छैन त्यसपछि म हजुरको हेरिरहेको थिएँ
ए होइन त्यो सिम्पली प्रम्प्ट मैले भन्नु है के लेखाएको थिएँ मैले पनि त्यही प्रम्प्ट नै कपी गरेको हो त्यही सेम अघि संस्कारले दिएको प्रम्प्ट कपी गर्नु अनि तपाईँको टपिक रिप्लेस गरिदिनु अनि मेरो त जेनेरेट गरेर
मेरो
डेटा साइन्स
जेसनमा गऱ्यो होइन म यहाँ देखाउँछु ल ल
ल
मेरो यहाँ रिसर्चरलाई दिएको थिएँ मैले होइन अनि जेसनमा गऱ्यो होइन कपी कपी गरिसकेको छैन मैले देख्नुभयो तर त्यो फर्मेट पछि आउँछ होला होइन म कपी गर्छु है त
तपाईँले यत्तिकै बाहिर फाइल बनाएर त्यसमा पेस्ट गरिदियो पनि हुन्छ
टेस्ट 1 भन्ने गरिदिनु न
ट्रेनिङ डेटा भनेर लेख्नु न ट्रेनिङ र भ्यालिडेसनको दुईवटा भयो भने तपाईँलाई बुझ्न सजिलो हुन्छ सेभ गर्दाखेरि चाहिँ जेसनमा सेभ गर्नु पऱ्यो त्यसलाई तपाईँले टेक्स्टबाट
ठिक छ यो आयो होइन
फाइल सेभ एज गरेर जेसन ए त्यो त मिल्दैन रहेछ
यहाँ डट जेएसन गर्न मिल्दैन
मिल्छ हेरौँ ट्राई गरौँ तलबाट सेभ एज टाइपमा छैन त्यहाँ तल टिएक्सटी मात्रै छ
त्यो त आउँदैन
त्यो अल फाइल्स भनेर सिलेक्ट गर्नु
होइन गरिदिउँ
एल पनि
मोस्ट
लेख्नुपर्छ
प्रोबेबली चाहिँ हुन्छ जस्तो लाग्दैन
होइन जेसन एल लेख्नुपर्ने होइन र
जेसन एल हो .com
जेसन एल
जेसन एल अनि JSONL .JSONL
भएन तपाईँले एकचोटि फेरि त्यो फाइल टाइप
ए
एज
भएन 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 भएन
यो चाहिँ भ्यालिडेसन हो कि ट्रेनिङ हो यो
यो चाहिँ ट्रेनिङ हो
दुइटै एउटै डेटा युज गर्न मिल्छ कि के गर्ने खासै
ए होइन होला भ्यालिडेसनको लागि चाहिँ त्यो 10% डेटा लिएर अनि त्यसले टेस्ट गर्ने हो कि डेटा होइन तपाईँको त्यो टोटल डेटाको कति 10-15% लिएपछि भ्यालिडेट गर्न मिल्छ क्या अरे त्यसैले क्रिएट गरिदिन्छ त्यही अघिकै प्रम्प्ट चेनिङमा गएर अनि क्रिएट भ्यालिडेसन डेटा सेट फर द ट्रेनिङ डेटा सेट अब भनेको थिएँ मैले चाहिँ त्यसपछि त्यसले 50को 10 डेटा सेट 50वटाकोमा 10वटा लिएर बनाइदियो मेरो चाहिँ
जेसन फाइल हाम्रो बन्यो होइन
JSONL ओके त्यही छ practice.jsonl हुनुपर्ने होइन त्यही
फेरि एकचोटि त्यो टेक्स्ट फाइलै ओपन गर्नु न
त्यही माथिबाट नेममा डबल क्लिक गरिदिनु भयो भने त्यहीबाट JSONL हुनुपर्ने होइन उसमा एनिवेज त्यसलाई
यहाँ
जेसन
गरिदिउँ
वर्माकै छ होइन
.JSONL L पनि हो नि होइन
हो
यति नै गरेको ल सेभ गरेँ
ल एकचोटि तपाईँको फाइलमा गएर हेर्नु त सेभ गरेको ठाउँ JSON
यही हो
मेरो चाहिँ स्टिल रनिङमै छ है अब तपाईँले त्यही सेम नभए यसलाई चाहिँ तपाईँले अर्को प्रम्प्ट दिएर क्रिएट अ डाउनलोडेबल JSONL फाइल भनेर भन्नुभयो भने त्यसरी डाउनलोडेबल फाइल बनाइदिइहाल्छ नि यहीँ प्रम्प्ट चेनिङबाट
ल यसलाई दिउँ होला भन्नु
अगाडि डट पनि हालिदिनु नि JSONL को अगाडि एकचोटि प्रम्प्ट हान्दिनु त यही त हो चेनिङ भनेर पढेको एक्जिक्युसन ल भइ त हाल्यो त्यही ल आयो तपाईँको जिएस
त्यो बेकारको किन टाउको दुखाइ गर्नु
त्यही त अब पढ्नु त्यो 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 नखोल्दै अब तल्लोपट्टि अर्को प्रम्प्ट लेख्नु न त्यहाँ त्यो अहिले छोडिदिनु तल क्रिएट अ भ्यालिडेसन डेटा सेट for the for the for the for the for the training data set above.
हजुर
Training data set above के ABOVE above. पहिला अघि माथि त्यो बनायो नि ट्रेनिङ डेटा सेट इन डाउनलोडेबल डट जेएसओएनएल फर्मेट भनेर भन्नु त जेएसओएनएल फर्मेट अब त्यसले तपाईँको भ्यालिडेसन डेटामा बनाइदिन्छ त्यो भएपछि त्यही माथिकै डेटालाई हानिहालौँ मेरो चाहिँ स्टिल रनिङ है
मैले एनालिस्टमा हालिरहेको छु टाइम चाहिँ लाउनु पर्ने अहिले
त्यो एनालिस्टमा चाहिँ गर्नु पर्दैन च्याटैबाट बनाइदिन्छ त्यति
ल
भइहाल्यो
भइहाल्यो रिसर्चरमा चाहिँ टाइम आउँछ नि त एनालिस्ट भन्दा यहाँ भएन डाउनलोड गरिदिउँ?
डाउनलोड गरौँ तपाईँको एउटालाई चाहिँ भ्यालिडेसन डेटा भनेर राख्नु पऱ्यो डट जेएसओएनएल चाहिँ चेन्ज गर्न मिलेन त्यो चाहिँ तपाईँको ट्रेनिङ डेटा हो होइन 726 मा डाउनलोड भएको छ ट्रेनिङ अर्कोलाई चाहिँ भ्यालिडेसनै भनेर रहेछ भइहाल्यो अब तपाईँ उसमा जानु पऱ्यो एजियर फाउन्ड्रीमा जानु त अब मेरो त स्टिल रनिङ छ त
क्वेसन के थियो अरे मैले त बिर्सेँ क्वेसनै बिर्सेँ
होइन अघिको जस्तै गर्ने क्वेसन त अब तपाईँको त्यो टपिकमा तपाईँको फाइन ट्युनिङ गरेर मोडलले काम गर्नु पर्यो के होइन केसी एम आई मिसिङ एनिथिङ
हो नि त्यही हो मेरो पनि लोड भइरहेछ अब त्यो अपलोड
तपाईँ चाहिँ फाइन ट्युनिङमा गएर अब फाइन ट्युनिङमा जानु पर्यो तपाईँ फाइन ट्युनिङमा क्लिक गर्नुभयो
हजुर
र अब फाइन ट्युन दिस मोडल गर्नु पर्यो अनि जिपिटी 4.1 न्यानोमा
न्यानो होइन
हो जिपिटी 4.4.1
सुपरभाइज भन्ने नै हो
सुपरभाइज नै हो ग्लोबल हो
ट्रेनिङ हो
अब तपाईँले एड ट्रेनिङ डेटा गरेर डेटा एड
ट्रेनिङ डेटामा
तल सिलेक्ट डेटामा ड्रप डाउनमा तल त्यो त होइन त्यहाँ छैन अप्सन एकचोटि बाहिर क्लिक गर्नु माथि ट्रेनिङ डेटामा हेर्नु नि तल त्यसमा हो त्यहाँ अपलोड फाइल गर्नु
अपलोड फाइल्स
त्यहाँ फेरि अपलोड गरेर तपाईँको ट्रेनिङ डेटा चाहिँ त्यहाँ अपलोड गरिदिनु तल अनि तल स्किप प्रिभ्यूमा गएर हेर्नु त
ठिक छ
त्यसलाई अप्लाई गरिदिनु अब तपाईँको भ्यालिडेसन डेटा पनि त्यसरी नै अपलोड गर्नु पऱ्यो नि
अरू केही चेन्ज नगर्नु भनेको थियो होइन सबमिट
तपाईँको
गरिदिनु
भ्यालिडेसन डेटा भ्यालिडेसन डेटा अपलोड गर्नु पऱ्यो नि त्यहाँ उ त्यहाँ
ए
एड भ्यालिडेसन डेटा ड्रप डाउन अपलोड फाइल भ्यालिडेसन त्यो स्किप प्रिभ्यू गरेर हेर्दा एकचोटि यसलाई पनि अप्लाई गर्नु ल अब यति भएपछि तपाईँको रन
अरू
क्युमा
केही चेन्ज
बस्छ
गर्नु पर्दैन खासै
अहिलेलाई परेन
सबमिट गरिदियो नि त
गरौँ के चाहिँ भयो इनभ्यालिड ट्रेनिङ फाइल हेज टु फ्यु इक्जाम्पल्स एटलिस्ट 10 इक्जाम्पल्स आर रिक्वायर्ड ए डेटा चाहिँ एकदम सानो रहेछ नि त
ल 10 भन्दा सानो रहेछ अनि
तपाईँको के अरे ऊ भयो क्या त्यसो भए ट्रेनिङ चाहिँ भ्यालिडेसन चाहिँ ट्रेनिङ भएको त होइन पाउनु फाइल साइज हेर्नु त
ए
त
दुइटै
त्यहीँबाट
3 केबी छ
ए त्यसो भए त धेरै सानो भयो त्यो तपाईँको एउटै साइजको मोडल डेभलप गर्ने र एउटै साइज भ्यालिडेसन त हुँदैन नि त अघि संस्कारले भन्यो 10-15 भने जस्तो लाग्थ्यो पर्सेन्टेजमा तपाईँले सिम्पल च्याटबाटै त्यो डेटा बनाउनु न त्यो एनालिस्ट यताउता नभइकन च्याटबाटै तान्ने हो मेरो त है
ल
Hey, has anyone not finished their training, or has anyone not started training yet?
We have been trying actually, as you can see.
No worries. Yeah. Keep going. This is good practice.
So we encountered an issue actually.
Okay.
What it said, like, training files as too few
So
examples.
it seems you need more examples. Yeah. You're gonna need more examples in the training data set. So it's prompt engineering, guys. Use your prompt engineering skills.
के भयो त माथि हेर्नु माथि स्क्रोल अप गर्नु त एकचोटि तपाईँको मेसेज रोल यतिकै सिधै लेखेर त त्यसले के बुझ्छ र के भन्न खोजेको हामीले क्रिएटेड डेटा सेट भनेर थियो नि त आई वान्ट टु के भनेर थियो नि त अनि त्यहाँ संस्कारले च्याटमा राखिदिएको हेर्नु त क्रिएट अ स्याम्पल डेटा सेट ऊ त इकेसीले नि राख्नु भएको रहेछ नि त त्यो चाहिँ कपी गर्नु त क्रिएटेड डेटा सेट भनेर अनि तपाईँको चाहिँ केमा गर्न लागेको त्यसले रिप्लेस गर्नु
सेकेन्डवाला हालेछ त्यो गर्नु त्यो सेकेन्डको मात्रै चेन्ज गर्नुभयो हुन्छ सुबोधजीले सेकेन्ड लाइन भयो अनि डेटा सेट कहाँ पुग्यो ए भएन है है फेरि त्यही हालेछ अर्को चाहिँ पठाउँछु भने
इकेसीले च्याटमै राखिदिनु भएको छ सुरुजी अहिले भर्खर राखिदिएको
तपाईँको चाहिँ त्यो तपाईँको कुन टाइटल हो त्यो राख्नु है तर सेकेन्ड लाइनमा
टाइटल चाहिँ चेन्ज गर्नु पर्यो
मैले चाहिँ नि ल्याङ्ग्वेज लर्निङ ट्युटरको गरेको छु तपाईँले के को गरेको त्यो मात्र चेन्ज गर्नु
मैले फाइनेन्सियल गराएको छु तपाईँले अर्को कुनै पिक गर्नु न च्याटमा हेर्नु न माथि
यो गर्नुको साटो छ नि अघिको त्यो जुन च्याट तपाईँले बनाइसकेको डेटा छ नि त्यसमा गएर इन्स्टेड अफ अ स्मल 5 डेटा क्यान यु गिभ मी एटलिस्ट 20 भनेर लेख्नु उसले फेरि जेनेरेट गरिहाल्छ नि
हो त्यो गरे पनि हुन्छ एड मोर डेटा भनेर
हैन?
अघिको प्रम्प्टमा त्यो क्रिएट भन्ने थियो र तपाईँको मन्जुरीजीले भनेको पहिलाको उसमा
हजुर
हजुर
Oh,
दसवटा
मैले
I
जुन
think
बनाएको
पहिला
create
डेटा
a
window.
small भनेको
किनकि
थियो नि त यहाँ small भनेपछि त भएन
होइन
नि त
मैले
ओके
पनि
यही
च्याट
create
जेपिटीलाई
a
भन्दा
small
उसले 5 वटा मात्र दिएको थियो कि पछि फेरि
त्यसलाई डिफाइन
क्रिएट
गरिदिनु
एटलिस्ट
नि त
20
त्यो
भनेपछि उसले एड गर्यो कि
आई निड टु क्रिएट एटलिस्ट भने कतिवटा डेटा मेरोमा 50 छ है 50ले चलेका तपाईँको भ्यालिडेसनको डेटा सेट भन्दा तपाईँको ट्रेनिङको डेटा सेट ठुलो हुनु पर्यो कि एटलिस्ट 20 नभन्नु एटलिस्ट 50-100 भन्नु किनभने तपाईँको भ्यालिडेसनको डेटा सेट त्यसको 10-15% चाहियो नि त 50 भन्नु
100 भन्दै न के नै जान्छ र
जाने केही पनि 100 डेटा सेट्स भन्दाखेरि फेरि छुट्टै डेटा सेट 100 बनाइदिएला
अनि यो त एउटैको मा जान्छ होला ल म यो हान्दिउँ
बनाएर हेरौँ
एकचोटि माथि जानु त तपाईँको केमा छ एक्चुअली हेरौँ वेबमा छ कि वर्कमा छ
मेरो वर्कमै हुनुपर्ने हो 100%
वेबमा राखेर
अहिलेसम्म
हानिदिनु न अलिक ब्रोड हुन्छ नि त
वेबमा
वेबमा राखेर गर्नु न एक्चुअली
वेबमा च्याटमा रेगुलर च्याटमा वेबमा
मैले चाहिँ वेबमै राखेको वर्कमा
हो?
भयो कि लिमिटेड हुन्छ जस्तो लाग्यो मलाई
तर हामीलाई त अहिलेसम्म वर्कमै गर्ने भन्ने आएको थियो होला होइन
वर्कमा त अब काममा हुँदाखेरि वर्क डकुमेन्ट हुने भएकोले वर्कमा तपाईँले चलाउँछ तपाईँको सबै काम सम्बन्धी हुने भयो नि त अहिले त हामीले स्याम्पल निकाल्नु लाग्ने मात्र वेबमा अलिक ब्रोड हुन्छ भनेर
मेरो स्टिल रनिङ
ल म एकचोटि एक्जिट गर्छु है त्यो
रिटर्न द ट्रेनिङ फर्मेट डाउनलोडेबल भने भए डाउनलोड गर्न मिल्थ्यो होला पहिला फाइलै रेडी भयो ल 100 स्याम्पल्स
वर्कमा चाहिँ नदिने रहेछ कि
अब
आयो त
यसलाई डाउनलोड गरेर अर्को प्रम्प्ट लेखेर भ्यालिडेसनको डेटा सेट पनि डाउनलोड गरिहालौँ
त्यसैमा कमेन्ट हालिदिनु अनि चेनिङ हुन्छ नि त हेरेर 10 वटा जति भ्यालिडेसन डेटा सेट पनि दिनु भनेर राखिदिनु
यसलाई
डाउनलोड भयो
डाउनलोड
त्यो
गरिदिनु है त
किन भएको छैन र अझै
यो क्लिक गरे कि डाउनलोड हुन्छ
क्लिक गरेपछि डाउनलोड भइसक्यो
तपाईँको डाउनलोड फोल्डरमा होला त्यो
ओके यहाँ अलि स्लो जस्तो लाग्यो मलाई
728
अनि डाउनलोडमा क्लिक गर्नु तपाईँ होममा छ जस्तो अहिले डाउनलोडमै
होइन म डाउनलोड फोल्डरमा छु यहाँ हेर्नु डाउनलोड छैन
होममा हुनुहुन्छ तपाईँ होइन डाउनलोडमा हेर्नु
रिसिभ
738मा हेर्नु त्यो चाहिँ हो 47 केबीको
यो चाहिँ अलिक ठुलो भयो
अब त्यसमा अर्को प्रम्प्ट लेखिहाल्नु त के अरे क्रिएट त्यो भ्यालिडेसन डेटा सेट वाला
data set create a validation data set
for the training data अब भनेर for the training अघिको त ट्रेनिङ डेटा हो नि त फर्मेट त मेन्सन गर्नु भएन यसले केमा बनाइदिन्छ चेनिङ भयो होला उसमै होला त्यसमै बनाइदिएला होइन बनायो होइन कति चाहिँ एकचोटि हेरौँ न साइज त्यो दुइटाको 9 केबीको भनेपछि तपाईँको त्यो सानो बन्यो ट्रेनिङको डेटा सेट चाहिँ त्यो पुरानो फाइलहरू डिलिट गरिदिनु त्यहाँबाट कन्फ्युज हुन्छ भने
म गर्छु
तलको दुईटा फाइल
पुरानोलाई डिलिट गरिदियो नि त
गरिदिउँ होइन त्यसलाई अब त्यो 1 हटाइदिए भयो भ्यालिडेसन र डेटा सेट भनेर आएको रहेछ अब बुझिन्छ त्यो अघिकै फाइन ट्युनिङको उसमै गएर त्यसैमा डेटा चेन्ज गर्दा हुन्छ होला त्यो होइन
यो त नयाँ कुरा आयो
त्यो होइन नि त
यहीँ होममै छौँ होइन
गलत ट्याबमा छ फर्स्ट ट्याबमा जानु फाइन ट्युनिङ
फर्स्ट ट्याब हो नि त यो यसमा तपाईँको एडिट गर्नु पर्यो ट्रेनिङ डेटा र भ्यालिडेसन डेटा दुइटैलाई
ल यसलाई प्लस गरिदिउँ है त
किन नयाँ बनाउनु लाग्नु भएको त्यही एक्जिस्टिङमै डेटा चेन्ज गर्न मिलिहाल्छ नि होइन र
गर्ने कि नयाँ गर्ने
कि बन्दै बनेन अघि
नयाँ गरौँ
युज गर्नुभयो पनि हुन्छ ठिकै छ
ल ठिकै छ
ल नेक्स्ट गरिदिउँ है त
बराबर
ग्लोबल
ट्रेनिङ
ट्रेनिङ डेटा अपलोड फाइल्स डेटा सेट होइन ओपन
भ्यालिडेसन
सफिक्समा के राख्ने भन्दै हुँदै होइन
नाम
तपाईँको
राख्नु
रेसिपी होला होइन
रेसिपी एजेन्ट भनौँ होइन सिड चाहिँ नराख्नु भन्नुहुन्थ्यो होला अरू सबै डिफल्ट हान्यो
सबमिट गरिदिनु
सब्मिट क्युमा बस्यो मेरो स्टिल रनिङ छ
भनेपछि टाइम लाग्छ अब
टाइम लाग्छ अरू कसैले सेयर गर्ने भए बनाउन सकिन्छ ज्यादा
Okay, nice. So is anyone LLM done training? Mine is still running right now.
माइन्ड
Is
स्टिल
anyone's LLM finished?
Cute.
Okay. So in that case, it's probably going to finish after class. So the last thing, let's go over one last thing, and then from there we can finish class. And then for homework, I want you guys to use that fine-tune model and see if you can get really good output. And if you get bad output, I want you to keep practicing to training those models. Okay. So you probably won't be perfect the first time, but after trying multiple times, you'll probably get better and better results. So I'm going to share my screen. I've created a little basically Python file here. Basically, it's a script that allows you to utilize Azure's API to make a call. It's only about 50 lines, 60 lines of code. It's quite simple. I've made this repository. I will post the link to this repository. If anyone's interested, feel free to use it. But it's not homework or anything. It's just something I wanted to show you. So if you ever, if you're a software engineer, you want to utilize Azure AI inside of your code or in any kind of feature, let me just demonstrate what this does. So essentially, so I'm going to call this file here, and I'm going to specify a prompt. So I'm going to say hello. And hopefully this works first try. There we go. So I got a response. So it says, hello. If you guys can see that, let me see if I can increase. There we go. So you can say, hello, how can I help you? So this is actually talking to one of the agents I set up in AI Foundry. It's GPT-5 Nano. But you can utilize this for any kind of model. Um, Essentially what it's doing is it's loading a .env file, and this contains basically the endpoint for Azure, my key, the model I'm using, and the model's version. You just need these four things in a .env file. And from there, you can load the file and call the Python file with the prompt you want to send. So this is where the user query is basically stored. That's when you say in like these quotation marks. And we save all of the endpoints, keys, versions, and the model by going and grabbing them from the environment variable. And we can set up an Azure OpenAI client, and then we can send or create a response with our message and send it to our the model, and then we can print the model's content. So this is a very, very simple way. You can utilize your agents that you create in Azure AI Foundry inside of actual code. This is using the OpenAI Python package. They have a specific package for Azure and for Azure OpenAIs, because this is a OpenAI compatible endpoint. It's basically the exact same endpoint as you would use for ChatGPT. That's the only package here that I really needed to add. This stuff is just, standard for Python. You just need it for your environment variables and your file here. So I will share this code after the class. I'm just going to clean up the README really quick. If you want to utilize this and try using your fine-tune model or another model you want to deploy in your code, then this is a great starting point. I think starting next week, we might go a little deeper into code, maybe some multi-agent workflows that we might get to see inside of code. And instead of having to write out this code, we'll obviously use AI to help us with that. Okay, so I just wanted to showcase this a little bit. Does anyone have, Subal, do you have a question?
So Scott, even if you have access to Azure in your company, do you, I mean, if you execute any prompt or anything, or try to create any agent, do they still charge you? I mean, is it that expensive?
So running a model like this, in terms of company, you might need permission from like your cybersecurity team. I can't speak on that, but what I can say is like running a simple prompt is not very expensive. It's very, very cheap, especially running a model like GPT-5 Nano. So there's a general rule of thumb: the smaller the model, like mini or nano models, they're very, very cheap to run. They're not going to cost anything to run, basically. So you can do this inside of a company environment. I would be a little careful. Probably let your security team know that you might be doing something like this if it's a problem. But other than that, you can do this, and yeah.
Okay, thank you.
Yeah. So I'll post this code afterwards. You guys can look through it. There's also a README, which basically goes over the steps to set this all up. If you would like to try it, go for it. It's not required at all. Just something I would share. So my model is still running here for status. I've been training this for quite a while. Now, before we end class, I just want to go over something really quickly. So I know last week we talked about how to delete resources. That is quite important. So what I will say is when you have these models deployed, you don't want to keep them deployed. Otherwise, they can charge you. So once my model is finished fine-tuning, and maybe I use it once or twice, the goal is to delete your models. You don't want to keep them in deployment because it might charge you for keeping them in deployment. And you don't want, obviously, we don't want that. So make sure after everything is said and done, you can go to this management center. So it's all the way down here in the bottom left. Go to this management center, and for whatever project you put your models in, just delete that project at the end, okay? Don't do this now because your models are fine-tuning, but once your models are done fine-tuning, you've used them and you're satisfied, make sure that you delete your project. And that way, it's not going to charge you for keeping your models hosted on their servers. Just to make sure that you don't just burn money overnight. That is just a PSA. Okay, everyone got that?
Let me share my screen. I didn't. My screen didn't show that.
So
Click on
scroll all the way to the
more,
bottom.
right?
Can you full screen? Can you full screen? It's down there in the bottom, but it's cut off. So there
Oh
you go
yeah.
on the bottom left there. Yeah. So yeah, you would delete that resource project. Don't do it now, don't do it now because you're fine
Okay.
tuning. But as soon
Yeah.
as you're done fine tuning, make sure you delete your resource, and then we
Oh,
will create a new one in next class, and then delete it again.
cool.
Yeah. Any final questions about how this is all working, or any questions at all?
So for the coding, Sanskar, are we gonna install Visual Studio for Python? Or
Yeah.
it's just okay.
Yeah. I think maybe if we have time, it depends on because I think next week we're gonna go over multi-agent workflow. So I'm gonna see if it's gonna be possible straight directly from Azure AI Foundry, but I think most likely we're going to need to dive into a little bit of coding. So if that's the case, then we might have to go through setup in
Mhm.
maybe next week. But I will figure that out and see what we can do.
Sure. Thank you.
Yeah. Any other questions? All right. So for homework for this class, I would like you to keep fine-tuning models. So when you finish your fine-tune model today, once it finishes, give it a try and share your output in the class chat. I want to see everyone's model, fine-tune model like outputs. I want to see what you guys were able to create and see if it was actually usable. Now, most likely, your models aren't going to be that smart, or they might not give really good outputs, and that's normal. See, the data sets that we created are kind of small, and fine-tuned models require a lot of data, depending on how big the model is. But generally, like GPT-5 Nano requires a lot of data, even though it is a nano model. So once your model is finished fine tuning, I want you to post in the chat your outputs, and I want to see how they performed, as well as try fine tuning on a larger data set. Try different methods of fine tuning and see what kind of outputs you get. And this is just more of you exploring the fine tuning aspect. There's a lot that goes behind the scenes, and Azure Foundry does do a lot of abstraction over it. But the more you can explore and try different data sets, try different types of fine tuning, the more you'll be able to understand why fine tuning is very important, as well as like where it can be effective. So homework is not exactly very concrete, but I really do urge you to try and fine tune a model with different data and try with different topics. Or if you want to do instruction tuning, you can do that. If you want to do reinforcement learning, you can do that as well. Just try new things. Okay. Subal, do you have a question?
So so once like it's running right now. So once it's done completed, we should be able to ask all of the questions, right?
Yeah,
Regarding
so
to
you'll
this
so you'll
agent.
do the exact same steps. Yeah, you'll do the exact same steps. You'll
Mhm.
click on
Right.
use model or deploy or something. You'll deploy the model and then go to playgrounds In the playgrounds,
Mhm.
you'll be able to select it and try it out. Okay.
Okay. So
Just
we're
make
gonna
sure
have
you
that
give it a
session.
system prompt. Yeah.
Okay. So that's gonna be for the next week, right?
Next week, we're gonna look into like a multi-agent systems.
Okay.
Yeah. Any last question?
But we
Oh.
want to have this session as well to be continued. I mean, the results and everything, or no?
Yeah. So once your model is finished fine-tuning, try it, and then
Mhm.
send you like a screenshot of your outputs in the chat, and then I want to see like what kind of model it was, trained on, or how the model trained.
And
Okay.
when should we delete it? When?
After you've submitted a screenshot.
Okay. Thank
Yeah.
you.
Mm-hmm. Any other question? Okay, so that's it for today. If you have any questions, you are free to stay here. But other than that, hope you guys have a good week. Please post your outputs and results, and then please make sure to delete your resource once you've done that. Your model is going to finish training in probably the next hour, so just keep checking on it, and then make sure you delete it once you've submitted your output screenshot, okay? Thank
Sure.
you, guys. See you guys
Thanks.
next week.
Bye.
I think
Thanks.
I'm gonna do it tomorrow. Okay. Bye.
Thank
Okay,
you.
see you
Have a
guys
night.
next
Yeah.
week.
Have a good night, everybody.
Good
Bye.
night.